So, as Erica mentioned, I'm Jennifer Lee. I will be today's moderator. What I'm particularly excited about is today's topic, the future of the data warehouse, and how data warehouses have evolved from powering analytical workflows to new use cases. As an enterprise investor at Andreessen Horowitz, I spent majority of my time actually on the data and analytics infrastructure space. And the reason why I'm so excited about this space is not just the 100 billion market cap of Snowflake. It's actually from my own experience. Because prior to investing, I was a product manager at companies like AppDynamics and a startup called Solvy, where I had to actually stand up the analytics stack to understand the product performance and correlate that with customer satisfaction and the business metrics. We went from Teradata to Redshift and then went to Snowflake, and we spent a month to gather this data, put it all together in one place. We still had challenges to make use of it and put that in front of the sales, marketing, even customer success operations team beyond just looking at the dashboards. And I'm sure a lot of the panelists here would have had the similar experience as me. So I have wished the products like dbt or Census or Indicative and Materialize have existed when I was a product manager, which makes me very excited to introduce you to today's panelists. Boris, the CEO of Census, Arjun, CEO of Materialize, and Jeremy, CEO of Indicative. To get us started, maybe we'll talk about, since all three of you and your products work very closely with data warehouses or leverage it in a particular way, for the audiences who are not familiar with what your company does, tell us about what does your company do and what led you to this space of analytics. Maybe we'll start from Arjun.
Hi, everyone. Arjun, Narayan, co-founder, CEO of Materialize. The reason Materialize exists is we thought data warehouses should be a lot faster. We think data warehouses are emerging as this sort of central clearinghouse of data throughout the enterprise architecture. As we can see this with the rise of companies like Snowflake, where there's what we've seen over the last decade is an explosion in the number of sources that feed into the data warehouse and an explosion in the number of applications that make use of data out of the warehouse, like Census. And we think all of that could benefit from being a lot faster. So that's really what Materialize is. It's a streaming database. It sits there consuming all of your input streams in real time and gives you views, hence the name Materialized Views, being the database concept for keeping a query fresh as the underlying data changes. And that's why we found it Materialize.
And maybe a couple of quick sentences about what led you to this space, Arjun. I think your experience is quite relevant as well.
Yeah, so I've been in the data and distributed data space for a while. I did a PhD at the University of Pennsylvania on security and privacy aspects of distributed data systems. I got more into the broader space. I worked at Cockroach Labs as an early engineer, working on Cockroach DB, a distributed database. And I've been a longtime fan of my co-founder's technology, Timely Data Flow, which I worked on, which is really a next generation database engine. It's a streaming engine that allows for maintaining these queries live, even when the underlying data is changing really fast. And so I've been in this space for a while, maybe a little too into the weeds. So hopefully I can step back here with your help.
Awesome. Next, Boris.
Hey, so I'm Boris. I'm the co-founder and CEO of Census, and I've come at this space after years and years and years of just struggling with the pain of kind of data being distributed in the company, in the not in the technological sense, but in the human sense, and no one having kind of any kind of consistent view of what reality was. And so we made Census such that you could connect directly out of your data warehouse to Arjun's point about there's this amazing explosion of data sources, and the warehouse can be this clearinghouse for understanding that data. And what Census does is makes it seamless for every other team in the company to benefit from those insights and that distillation of data. So we make it so that you can kind of one-click connect your data warehouse to Salesforce or Customer IO or whatever app your business team is using, so that everyone can agree on a single definition of data.
Awesome. Jeremy?
Sure. So I'm Jeremy Levy. I'm the CEO of Indicative. We are a customer analytics platform that's designed specifically for product and marketing teams to allow them to perform complex analysis on the customer journey without the need for things like SQL or a data analyst. What makes us particularly special, and the reason that we're here, is that we're the only customer analytics platform that connects directly to a data warehouse. Now, in terms of why we built this platform, by way of my background, I was the co-founder and CTO of two previous businesses. The first one was a dating company way back in the mid-2000s, and the second one was the first mobile enterprise CRM. And we generated huge amounts of data, but we really struggled with how to go beyond the traditional dashboarding reporting use case for that data and use that data to actually inform decisions about our product and about our business. And so we built Indicative really to solve that problem. And again, that is really how can we empower product teams to leverage this plethora of data to actually inform the decisions they're making. I will mention, though, I will be remiss and I will get called up by my marketing team if I don't mention that you can go to our website and you can actually try out our product by going directly to www.indicative.com.
Awesome. Thanks so much for the introductions. Actually, from your introductions, I think it's pretty clear that there's tremendous advantage of building company or products on top of a data warehouse, given it is becoming the source of truth, or it's becoming this clearinghouse, as Boris mentioned, where all the data you wanted to get around the business, you can get it from data warehouse. But what are some of the disadvantages that's not obvious to audiences here when you're actually leveraging or sending data from or to data warehouses? This question, I'll start with Jeremy.
So, I think obviously we all believe that a data warehouse is the right direction in terms of the way the industry is moving. So I think I'd be hard pressed to say why you shouldn't use a data warehouse. What I can say are what are the risks associated with using data warehouses. I think one thing today is that since there is a large amount of fragmentation in terms of the types of technologies that you use, you have to be careful to choose the right type of technology that supports your use cases into the future. As far as why you shouldn't use a data warehouse, I think everybody should be using a data warehouse. And I think what's really incredible about where we are today is the fact that data warehouses can be used by virtually anybody, whether you're a startup that has no funding or you're a Fortune 500 company. What's amazing today is that you can actually use the same underlying technologies, and that will scale with you as you grow. But I think, again, my point is, figuring out what is the right technology, the right approach, I think is a place where there is risk with choosing a data warehouse or a data lake and your data stack, so to speak.
I think, Jeremy, your point about it's perfectly scalable from startup to large enterprise is the best feature of these data warehouses. It's also like with great flexibility comes like the problems, right? So I'd say warehouses have two problems again, not problems, but like dangers that you have to watch out for. One is they give you infinite flexibility. So there are no guardrails. There's no like, this is how you should structure your data. It's just an open field to do whatever you want. So the onus is a lot more on your team to figure out how to structure that data, right? One. And then two, to Arjun's point earlier, there is an explosion of sources and there's a lot of different ways of getting sources into your data warehouse. And so understanding the latency of your data, and I say this so that Arjun can kind of knock this out of the park, but like understanding the latency of your data is difficult. It's not something you just get out of the box. And as you use your warehouse for more and more things, people have to understand what the latency of that data is.
Awesome. Anything to add on that, Arjun, especially on the latency?
Yeah. Well, thank you for taking that up, Boris. Yeah, I definitely think the biggest weak link of using data warehouses as the source of truth is the speed or lack thereof at which they update, right? They're tremendously powerful, tremendously scalable, and these are all benefits, but that comes at a cost, which is really that the data refresh speed is, and it's oftentimes, it's not so much that it's the data refresh speed of your slowest source, talking about the explosion of sources. It's actually worse than that, because one thing that you often need to do is, let's say you have a view of your data that's joining 3 sources upstream. You're going to be as slow as as you can, not just the slowest of your streams, but the slowest one of your streams lined up with the other streams, right? So if you're doing a join on some key, you kind of need to wait for all the dumps to happen and then you begin the processing. So it's for many companies where we talk to, it's often measured in days, even though like any one of these steps is maybe an hour long. Just the fact that you got to wait for Europe to close and then Asia to close and then North America to close, and then you can start lining those things up, doing the ELT, and by the time that happens, it's been another day. So that latency can really add up.
Great. And that's where I think we can move into, so this transactional nature of the data where you expect low latency and would like to be able to leverage the data to run analytics queries, but maybe the data hasn't arrived yet to the data warehouses. That's sort of the tension we see between what people used to use, let's say a database versus like OLTP system, where it powers more of these transactional data. Where we're seeing this kind of the convergence of data warehouses being used more and more into those transactional and operational use cases. For the people who are not familiar with this transition, I would love to hear like what is new in this new generation of data warehouses that makes it possible, where, as we all know, data warehouses existed for decades, but it wasn't as possible as today to power some of these workloads. We'd love to dive into the architectural or technology changes here.
I mean, I think the community here is probably pretty savvy, but there's the first level, which is only in this generation of data warehouses have we managed to separate storage from compute, and more importantly, separate workloads within compute from each other, right? So two users in Snowflake can effectively scale infinitely in compute without hitting on each other, which is not the case in even just as recently like Redshift, right? Which is not even that old. So I think that's the biggest change that allows people to start exploring more uses of the data warehouse than just a nightly or monthly analytics batch process, because that used to take the entirety of the resources, and anyone else touching it would cause like a brownout. So I think that's probably the dominant reason why this is evolving. It's also a lot easier to deploy, like to Jeremy's point, right? Like you can set up a Snowflake instance or a BigQuery instance on the order of minutes, technically. Setting up, a Hive, a Hadoop setup 10 years ago was quite a bit longer than that.
I would agree with you, Boris, but I would take it even a step further, which is the advent of cheap storage, cheap compute, and then secondly, this generation of cloud data warehouses that have unique profiles in terms of how they scale and how they grow has created space in our ecosystem for new categories of products that were previously handled by monolithic data warehouses. And so because BigQuery scales infinitely without having to do this or do that, it's allowed companies like dbt, for example, for Indicative for that matter, for your company as well, to create these spaces that fill all these gaps. And because there are spaces, the cost of entry is so low, it allows entrepreneurs like ourselves to create and innovate incredibly quickly, creating all these solutions, which is giving rise to what effectively is this wave of power or the ability for us to utilize all this data in ways that weren't possible when a handful of companies controlled the gateway or to having a data warehouse. That is what I think is so interesting, is that there's so much more opportunity for entrepreneurs like ourselves to solve all these little nuanced problems. And I also think, by the way, that speaks to where our industry is going into the future, whether or not there will be consolidation of many of our types of tools into these larger monolithic application, data warehouse applications by way of whether it's a Snowflake or AWS or Google and so on. But it's a great time to be in data right now because of the opportunity.
Yeah, no, you're right. And they're open platforms, right? And that's a key part of that for sure.
Absolutely.
And there's one point you mentioned, Jeremy, that's really interesting, is this democratization of access of data, not just for founders like you all, but also to people within a company, whether they're the people who are not on the data team itself, not on the analytics team, but the sales operations, marketing operations, or product teams, engineering teams who can get their hands on to this data, where it used to be all in the silos of the Zendesks, the Salesforces, and the Marketos. Now you can actually do the correlation and merge the data and actually generate more interesting use cases. What I'm curious about is, as this kind of motion going into teams and companies, do you see the tension of people who owning the data warehouse, let's say the data team, versus the teams who are trying to make uses of the data to have some sort of disagreement, problems to managing the data in a very coherent way? If so, what are those problems or phenomena look like?
I mean, I probably deal with this more than the other two here, although Jeremy probably deals with it too. So, I mean, of course, there's going to be disagreement when the first one that everyone always thinks about is when you're first starting to integrate more closely between a data team and the rest of the business. Step one is you make reports, and then people find out at the quarterly business meeting that like these reports don't agree with what the marketing and sales teams have been saying. That's one problem. But once you go deeper and actually integrate directly into the operational business workflows, then you're going to have some initial pain. A lot of times, it's like a upfront cost that you have to bear as a group of humans to say like, why are we disagreeing on this data, and how does this affect me? But over time, that becomes a steady state. But I don't think the idea of zero conflict is reasonable in a company, right? Like you have some amount of back and forth. But I think the main value of enabling the data team to serve the rest of the company in this way is that you move from working in silos to actually working together, right? And that does come with organizational change, and you might have to, kind of forward deploy a data analyst for a while, or educate your peer groups about how the data is structured. But it is much, much better than the alternative, which is that they will work around you completely, right? Which is kind of what I've seen historically.
Great. And how do you see people actually like working to? What are the examples? Let's say you see people working together as they're collaborating.
Yeah. Totally. So I think there's a couple different things, right? One is setting up, some kind of like there's very basic human things, right? Setting up the right conversations, right? Setting up the right Slack channels, the right groups around, bringing in one group out of the ops teams, let's say the customer success ops team and the data team working together on one project, and then letting that be successful, and then helping that kind of spread across the company. So instead of trying to boil the ocean, you start with one group and you create, like async and synchronous like check-ins on what they need, and you start iterating on that. Two is, some of this stuff is basic, but you can start by creating a ticketing system so that some of these workflows become easier to track, right? And then more importantly, I think you start to distill, and this is the role of the data team, in my opinion, is to distill the needs of multiple teams into a common set of data points. So I think that is where the data team adds the most value. And you've got to move away from the best teams that I've seen, move away from one-off, like feed data, make a report, into I understand the needs of these teams. What we're going to do is build this data model that is, unified and pulls out like the core analytics that we care about and these core metrics, and then we feed those out to everybody and explain why these are the kind of correct definitions of things. By the way, the last thing I'll say is sometimes conflict is by design. So this especially happens between accounting and marketing and sales, and where the data team sits in the core, right? And so conflict is actually a feature, not a bug in that situation. You actually want to have the kind of reconciliation kind of conflict meeting. And the right place to do that, at least on the data side, is in the data warehouse, where everything meets and you can actually kind of see what the discrepancies were.
I think it's important to remember that, data teams versus business teams are all aligned amongst the same goals. So to the extent that we're setting expectations about what are the objectives that we have with our data, gives way to the ability to democratize that data across an organization. So specifically, I have to make sure when we work with customers that the data team is on board with the types of data they want to expose from a customer journey perspective, and that data is synthesized, whether it's from the source, collected, transformed in a way that is consistent, that allows business teams to self-service that data. And what we often find is that there isn't necessarily a conflict between data teams from an analyst perspective and business teams. Data analyst teams are oftentimes excited to work with data tools such as Indicative, because it allows them to work on more substantive or more value-added work from their perspective. It allows the whole notion of data warehouses exists to drive value, and that value falls into the analytics use cases, the operational use cases. The more we can move the analytics-based use cases to the business teams, I think actually removes conflict, right? It puts the data in the hands of people who are making those decisions.
Yeah, it's true. I think autonomy where you have correctness is great, right? Like that's the key. The data team abstraction layer should be about like correct data models, and let as much of that become self-service after that to the business teams.
Well said, yeah.
Yeah, and I particularly love the point, Boris, you made. Sometimes like this conflict is by design, and it's a good thing where people have seen the clarity and have the transparency of what's happening across organizations. So you can actually pinpoint a problem, maybe even troubleshoot it with more enhanced data from other organizations, whereas it wasn't possible if it only lives siloed in one organization.
Yeah.
And to Jeremy's point, enabling the analytics workloads for not just the data team, but push it down to the business operating teams and make it more actionable through what you're seeing in the warehouse, not just build models and dashboards, but also like push it down into actual use cases. What it can do is what's essentially the value of what we're doing here. Where I am curious, like we talk about there are like the successes when this is implemented right, but when sometimes, given this is still sort of relatively new phenomenon, it wasn't really the case where people used to work before. Like you had the reports generated by the sales ops team, and you have like a centralized report generated by the central BI team. Now that we have this motion and the clarity and transparency, what are some of the failure modes you have seen that may either cause the successes of the data team or causes the pain of managing the data warehouse for both centralized data team or the specific functional organization?
At the risk of being controversial here, I will say that one source of conflict is around data duplication. So the notion that you're duplicating data from whether it's origin, where it's being collected, is often a source of conflict, or even duplicating it out of a central repository. I think, to use Boris's term, out of your central sink of data can also be a source of conflict. I'd say, something that people don't always understand, and I hesitate to say this because I think people could react negatively to it, is, if you measure something twice, sometimes you get two different results, and that is just the reality of what happens in data. Data doesn't always back out to, a 10,000th of a percent. And I think some people expect, because it's numbers, because it's math, it should always line up perfectly. And that's really not the way our systems work, and nor would they ever be. And I think that's one big source of conflict that doesn't get enough attention.
That's a really strong point. So I was going to say two things. One that I'll leave as a second to lay up for Arjun, but the first that I've seen, when you start to integrate, like I said, data teams into these operational workflows, the biggest source of danger that has emerged, or like the pain that you have to now manage, but it's all about making yourself better, is that the negative impacts of bad data become much worse, right? So if you have bad data, normally your BI report is wrong and someone gets angry 3 months later and there's a meeting and like you fix it. But when you're pushing live data into live operational workflows, right? That means like someone's going to make a sales call that's going to be wrong, or we're going to send really bad emails, right? Or we're going to send dramatically too many emails, or something like that will occur. And so the cost of you having bad data becomes higher. And as we push more and more businesses towards being automated and leveraging software and technology and data, like that's going to happen. So you can't kind of hold the tide back. You only have to, so you just have to improve your testing and your staging process and your deployment process for data. That's just a natural outcome that we see when we work with teams. The second part, which is to Jeremy's point, and I'll leave it to Arjun, is when you build systems like this, effectively, it's already a problem in the traditional design of distributed data, but when you involve the data team and you now have a distributed systems kind of approach to this, like in reality, and business teams often don't understand. So it's to Jeremy's point about you ask the same question twice, you get different results. It's often not because the data is different. It's like you have, again, a latency and an eventual consistency problem that teaching regular people about eventual consistency is, I haven't figured out how to do it. and so that's definitely another kind of problem that people encounter, which is how do I leverage the data if it's I don't know exactly when it's going to be correct.
Yeah, that's so to add on to that, I think some of these problems come up because we don't yet have the cleanest story on what is the best way to operationalize an analytics or an ad hoc query, right? So the way a lot of these journeys go is it doesn't start with a grand vision. It starts with a data team or an analytics team says, "Oh, that's funny. That's really interesting. I want that. I want to monitor that number every day." Sort of, it goes from having been a one-off exploratory question towards becoming a pipeline. And we don't have the greatest story for taking an exploratory query and then making it into a robust pipeline. And the stories that we do have today involve extremely large costs. So, fundamentally, these data warehouses are not designed to be refreshed every 5 minutes with a new ELT ingest, right? So not the cost really balloons, and which is it's solving one problem, which is at least now you can have it. It's expensive, but we do want to sort of bring the cost down over time. And in creating these operationalized pipelines without the investments as a sort of community or an ecosystem in making it really painless and easy and hands off, these pipelines, it's not quite that they break, but they break in these weird ways.
Well, here's the thing, right, Arjun?
Attributed to is they break like this. Breaking is actually fine. It's
correct.
When
breaking is not the
a
problem.
slow pipeline is oftentimes worse than a broken pipeline.
But here's what I was trying to say. Maybe I'm jumping one step further. Right? It's like we give people these like seamless pipelines, but then you have a new problem that emerges, which is, I'm telling you, like a lot of business operations teams don't have a concept of staging. Like they don't have that, whether because their tool does not allow them to have it. Not everyone has a Salesforce sandbox. Like other tools just don't have that concept at all. And then therefore they don't think about their job in terms of test, stage, prod, right? And so there's a lot of, even if you, in fact, when you give people seamless data pipelines, you end up accelerating the need to kind of build those processes into it, right? I think that's the key. Like the data teams are all well on their way in this journey of like becoming more like DevOps over the last decade, right? Of thinking about configuration management, deployment, testing, staging, et cetera. BizOps teams are not there. And so that's really a lot of where the education is going to have to go that direction, right? I think the data teams should think about their peers there in terms of like, let me help you get seamless data, but let's make it safe for you to operate on this. And the way you do that is through some kind of, kind of configuration, like kind of CI.
Yeah, really great point that like data engineering or analytics engineering has evolved into a more like engineer approach that we're adopting the different environments and the testing frameworks and approaches have been tested by developers for decades that's applied to data now, but it hasn't happened really in the business teams to develop this developer mindset of doing like following the same workflow to guarantee the accuracy of the data. But I'm curious, even in a well-tested, well-built data pipeline, are we going to expect 100% accuracy or consistency when we're trying to analyze the data? And if not, what is the North Star we should look for as?
Always focus on the derivative, not on the, not on the vector, right? So it's like velocity, agility is what matters in a company, not getting everything correct at any given point in time.
And also the use case. Some use cases, if you're doing accounting for finance, you may want to be very precise. If you're looking at something in terms of that suggests a trend from behavioral perspective, having it be less accurate is not a critical failure of your data.
Yeah, totally.
But I do think we're on an endless journey. Like the ad tech world was super imprecise at the way they warehouse data, and they're like, vaguely we think you want a Lexus. Like the data is getting more precise as we invest in these kinds of teams and products. But I do think what matters is that you're improving and changing and adapting. Because let's say you got it perfectly right, and like 10 minutes later or 10 weeks later or 10 days later, it's like, that's the wrong workflow. Like we've discovered that was not the right way to engage with customers. So it almost doesn't matter, whether the data is perfectly accurate. It more matters that you're kind of in a permanent exploration loop.
Great. And I'd love to hear your insight too, Arjun, given I think Materialize is more analyzing the data as it arrives with the streaming data. Like, how do you think about sort of this accuracy versus latency, or like acting on the data? What's the balance there as you're seeing?
Yeah, by far the biggest challenge we see is that the data warehouse or sort of the later stages of the data pipeline it's a challenge to fix up data into a consistent view when much of the information needed to keep things consistent has been lost upstream. So if everything was in some perfect world starting in a consistent database, you're gonna have a much better time. But of course, A, that's not the reality, and B, well, you still have to deal with it, right? You have to you can't just say, well, you can't just throw your hands up in the air. Consistency is data consistency and data correctness is a organization-wide challenge. You can't do it at the warehousing layer after mistakes have been made upstream. So that's my biggest takeaway, is that one needs to look at the comprehensive sort of data stack in coming up with a story here, and it's not something that can be solved post hoc.
That's a really good point. I wonder to what degree data teams like struggle with putting band-aids on something when if they were to zoom out and affect the team at a higher level, they would have better success. It's a really good point, Arjun.
Awesome. And I see people discussing in the Slack channel where this kind of upstream data and the latency from the upstream data impacting downstream, as we're thinking about the data accuracy, the data consistency, and even latency when we're trying to act on this data. Is there any best practices or like hidden spots people may not have explored that you have seen for like really a well-organized organization solve this data through working together with other teams, or have explored technology-wise that have solved this problem of keeping the data, like not wasting a lot of time to figure out where does the problem come from, or once they know there are some problems, like being able to troubleshoot it and find out what causes this latency or inaccuracy, they can pinpoint that pretty accurately. Any tips or advice on that?
Well, I can speak to this a little bit from the data collection side. So our company works a lot with customers who bring their own data to our platform, and we spend a lot of time with them because we are essentially the front end for a lot of that data and helping them validate that their data is correct against their applications. And so what we recommend isn't even so much of a technical solution as it is treating data like you would any other technical project. It requires requirements, it requires validation, it requires, to Boris's point, maybe even a staging environment, but data collection at the very least, and following through to validation, requires attention at every level. You have to think through ahead of what is the data that I'm collecting, and can I validate that it's being collected properly, let alone is it being stored properly and then read properly. But it needs to be treated with a level of requirements and forethought, as opposed to what we see with a lot of people or a lot of companies, is that at least from an analytics tracking perspective, it's treated as an afterthought. I build a feature and then you're about to launch and you're like, wait, we forgot to instrument this thing, so that we don't actually know if it's going to be utilized or if it had the desired output that we have. And like I said earlier, depending on how you measure something, you can get different outputs. If you say people who registered, does that mean they clicked the registration button? Does that mean they arrived at the page after registration? Does that mean that they were successfully validated? Unfortunately, there's a lot of nuance in how you talk about data collection. And that needs to be thought through at the same level you're talking about designing the feature requirements, the product requirements for a given product.
My first job was a program manager at Microsoft on Visual Studio. And this is back in the days of people writing very large specs and before agile methodologies were a thing. And that was a line item in every spec, was how are you going to collect the data to confirm whether this feature is doing what you think it's going to do, right? So I think the key as an organization, as a data organization, to Arjun's point about like you have to move upstream, and I think we are now moving towards a world where there will be slowly but surely more like chief data officer type roles, and the data team is going to have a kind of company spanning impact. Again, on this front, I would focus on the derivative, right? Which is, it's one thing to say every product feature has to factor in data collection. And the key is like, how do we make that as seamless, as easy as possible, right? As opposed to this complicated tax that everyone wants to work around. So the seamlessness is part of it, right? Both in the sourcing and the publishing of data from the data team, like that, you want to make that continually as easy as possible so that you can then focus on the value add, right, on top of that.
Great. What I hear is know what you're looking for, define what you're looking for, and how did it arrive into the data warehouse. With that as a get post, still make it easy for teams to contribute the data, but without compromising the quality and the consistency of your overall sort of analytics goal. Great. With that, I'd love to turn into our next topic, which is looking into the future. Actually, we're already, as we were talking about, I think we're already entering this future of making data warehouses not just powering the analytics workloads, but more and more use cases built on top of it, given the power that it introduces. Maybe talk a little bit about what are some of the other use cases you are seeing emerging that can be mainstream in the next 5 to 10 years.
So I can take a stab at that one also. I think the ultimate goal of all of our platforms, of all of our products, is to derive greater business value. And I think there is in one area that still is not really easy for business users to use is moving beyond the dashboard and reporting use case. So in other words, I think it's by and large a solved problem to build dashboards today, certainly to look at reports, but to take that to the next level where people today have to use things like R or Python to do much more advanced analytics is still well out of the reach of your traditional business user. I'd say by and large, almost all business users. And so there's another stage sort of at the top of the value pyramid, the analytics pyramid, whereby automating or creating better tooling around building more advanced type analytics that help understand the why things are happening and that help drive outcomes. That analytics tools don't exist today. And that's very much where we think about, we're trying to move our product, which is how do we move to a place where we can tell our users not what happened from the perspective of a report or a dashboard, but help them predict and understand why these things are happening and why they're driving outcomes. That I think would be incredibly exciting. Now, can I tell you the timeline for that? I don't know, but I mean, certainly that's something that has not been solved yet. And I'd love to see, and that's an area where we're focused on.
I think Jeremy, you're very right. I think the on the spectrum of the quality of the analysis, it's amazing how many people think they want to buy some random AI product when what you're really just doing is trying to figure out how to do a logistic regression, and that's about it. And you'd be very happy if you knew how to do that in a way that was not wizardry. And so I'm totally with you that we're not anywhere near the end of that kind of innovation arc. The way and it was talked to death yesterday too, from what I understand. But of course, like I think just about all the ways in which a data team can be in the critical path and drive action. And I think we're very much at the infancy on that front, right? Like so many companies are, I don't know what the word is. Someone was saying this to me yesterday, like, data informed versus data driven. And that we're starting, you can talk about how do you make marketing more automated. That's a lot of people have been talking about that for years. And I think we're well on our way there. But I think other parts of the business, like you talked about accounting, or we mentioned it earlier about conflict, but how long does it take for people to close books? And why? Why is that not way shorter, right? And data has something to do with that, right? And the tooling and the kind of analysis, speed of analysis there matters. There's also, I think, a broader secular trend here that is the data warehouse is participating in and I think enabling to some degree, which is we're clearly in a 10-year journey of people wanting to own their data and being less, we talked about the distribution of data from a correctness and complexity perspective. And there's also this privacy angle, right? Wanting to understand all your user data and knowing where it is and kind of trying to harness it into one thing so you can reason about it and control it. And I think that is, the warehouses are going to play a big part in that over the next decade. And I think we're also just at the infancy of that. How to build privacy controls into the warehouse, right? Where you're going to have PII data in one namespace, but not in another. And there's a transition point between the two. Like there's a lot of things like that I think will emerge over the next decade.
Totally. What about some exciting streaming related or near streaming related use cases?
Yeah. So even without jumping to streaming everything, I think I do believe that all of these things will become real time, of course. But I also expect a continuation of existing trends, first and foremost. So we talked about an explosion of data sources. Well, we're going to see an even more explosion of data sources, right? People are onboarding cloud SaaS tools that store core customer data, at an astonishing rate. And then all of that only makes the need for a source of truth to unify all that data even more. There's an even larger need. So I expect the data warehouse to be stressed more by having to, today it's 10 things. Next decade, it's 100. It's 100 different sources that have to be joined, that have to be maintained. People have to really get better at this core, like what happens to your data catalog where there's a schema change twice a week, right? So you bring on a new SaaS tool, every 3 days, that involves sort of a core schema change and a refactoring of several downstream pipelines that would love to sort of be automatically enriched over time, right? So some of that tooling, we're barely scratching the surface. Obviously, dbt is a huge part of that story right now, but I think we're really scratching the surface in terms of making it seamless to just start upgrading pipelines that have been running for years, that as Boris mentioned earlier, in a little bit in a CI/CD fashion. It's a continuously deployed, updated, upgraded pipeline. I would expect some amount of that. And of course, the latency problem gets worse over time as you onboard more and more critical use cases, as you have more and more data sources, and the pipeline as a whole moves at the speed of the slowest data source.
Totally. And to add up my perspective of the question, that the one trend I'm particularly excited about is this blurry line of dashboards versus data applications, where we have seen a lot of data applications facing, let's say, the end user, or you can call Uber, order a DoorDash pretty quickly. But since people are equipped with the data and within your internal teams, the data is more self-served, and there are more tools to enable actually business users to build on top of their data with some of the lightweight UI or lightweight dashboards, like data app framework, to make your internal operational applications to, let's say, focus on this region of sales teams, or focus on that region of operating, like making better customer service. Totally. That's something I'm quite interested in, and see applications in that.
I think that fits well into Jeremy's view. If you think of I don't know how many dimensions are there to this of evolution, but in the same way that analyses need to get stronger, and doing a bar chart is obviously fully solved, I think it's another kind of the chart plus is a kind of interactive app, right? And if we make that easier and easier for business users to do, then there's gonna be all sorts of interesting pressures, right, around, like, to Arjun's point, like, I was talking to a customer that has 300 SaaS apps. So Arjun, we are dealing with massive numbers at this point. And you're right, like, we should not underestimate the scale at which people will continue to have tons of SaaS. But at the same time, I think we're going to find this additional pressure from the business users to build their own micro app interactions themselves, right, in something. And yeah, that's going to be, the warehouse is probably going to play a significant part in that as well. We should figure out the interactivity part, which is, Materialize will solve that, or Indicative will solve that.
Great. I actually prepared a list of lightning questions that I think is really fun and interesting, and I would love to run that by all three of you. But I'll kick that off and start asking some of these lightning questions, and we'll go through a few to answer those. The first one, if I may pique interest, which will be the dominant language, do you think, for interacting with data? Is it SQL or Python?
I think it's going to be SQL, but I don't really want it to be. I think SQL has held us back in terms of limiting how we think about analyzing data, which is probably going to be an unpopular opinion. But I think
actually, Jeremy, I think I agree with you. I wish SQL were better too. I wish, I also wish C were better, but we're still with C, and I think we're still going to do SQL. Yeah.
SQL is great. I'm glad you brought this up, because SQL is great, because I think it's part of the reason we've seen an explosion in the data space. It's a common framework that has a huge amount of people who speak it. It's an interchange format for how we interact with products. But because of its limitations, it also limits how and what type of analysis we do. I'd love to see SQL go away.
I do think,
I completely agree. I used to joke that SQL is like x86. We all hate it. It's never going away. But maybe this is the year that things change.
Very topical, Arjun. Very topical. I was going to say, like, one thing going forward over Python, if we were going to do that, is at least it's hard, and SQL has tons of limitations, and it's frustrating. I wish it was composable at the very least, but it's at least effectively a declarative functional oriented language, which for a lot of users, if you give them imperative tools, they could harm themselves, right? And so Python giving you full power is great, but also dangerous. So I think there's some of the limitations of SQL are probably good for people to kind of thinking about modeling their data. But I agree that it would be nice to have something.
And for what's worth, I don't think it's going to be SQL. And again, I think it's going to be more of an interface that we develop than it is going to be a programming language per se. People have tried to get rid of SQL many times. If we think back to like the NoSQL movement of 5-10 years ago, like it didn't work. So I don't think it's going to be a language per se. It's going to be a different way that we interact with data.
You actually stole my next question. Will there be another language coming up to interact with data?
Say it again, I missed it.
Will there be another language being the dominant language interacting with data?
I think SQL is here to stay because it is so entrenched in every aspect of our space. But I think that we will evolve beyond it, if that makes sense.
So yeah, I think, look, I've spent most of my life working in programming languages, and SQL is just another kind of programming language. And people, it is it is basically impossible to move people to a quote unquote new paradigm. So evolution, yes, net new, like how many people do you know who use Haskell? Like it's not a lot. And so I think we might be able to get some improvements on it. I think it'll be very hard to do something wholesale different, but I think it's worth hoping for. I mean, I don't want people to stop trying.
Arjun?
I'm pessimistic. We're all in on SQL because I'm fundamentally pessimistic. A large part of the SQL value proposition is exactly the ecosystem. It's the fact that there's tools you can plug in. It's the fact that there's BI tools that speak SQL sort of out of the box. It's really hard to envision a world in which there's another language that also gains the adoption. Again, never say never. Like, I think I agree that, I have my own frustrations with SQL. There's many things that are very difficult that SQL sort of fights you. And yes, you can technically get it to do it, but it's a fight, and nobody ever likes that. I'm just pessimistic that there will be, and if similar to the sort of x86 quip earlier, if there is another language, it will certainly have to be spearheaded by a very large player that can get a lot of ecosystem partners on board very quickly. I think there's one such large player. I don't know what their plans are.
I will say this, right? So I will say that the feature, because people a lot of times want this feature, that feature. To me, and this is dating myself in software too, but like the number one thing that helps software scale, and writing SQL code is a kind of software, is composability. And SQL makes it basically impossible to compose. And that would be the thing I would solve for over everything else.
Totally. Cool. We're almost all SQL believers. Next question, whether stream processing will dominate batch processing. And when I say dominant, 51% or 50.1% is dominant.
It's interesting. I'm obviously very, very pro streaming. One of the things to realize is, there's more. So stepping back, there's more mainframes deployed today than at any point in the past before, right? Like, just because there is a new paradigm that has some advantages does not necessarily displace the old paradigm, because both are growing, right? And I think by volume of bits moved, batch processing will be greater than stream processing perhaps for the next 100 years. Will you, as a net new use case, build a batch pipeline 10 years from now? I would bet not. I would bet that it would be, once streaming is easy enough, once we bring the cost of adopting streaming, I think that's the primary thing holding streaming back today. It's just too difficult to set up a streaming pipeline, whereas it's very easy to just throw stuff in an S3 bucket, right? It just works with zero operational overhead, whereas keeping a Kafka cluster alive or any other cluster alive is work, right? Until we get that cost to be basically at that same free level for streaming, it's not going to be strictly dominant. But even after it's strictly dominant, you're going to see the old batch pipelines grow and grow and grow and grow and continue to grow, because they simply exist. There's tooling. It's a workflow that works, and things like that.
Yeah, I think to me, success over the next decade is not whether 51% streaming, 49% batch. It's, can we agree that there's a way to define schemas that span like that like to Arjun's point earlier about, you're going to have hundreds of sources and all these things, and you want to be able to upgrade a kind of a data model very easily across the org, and you're going to have like consumers on all sides of this. If you have to do that in two physical layers and two logical layers, like, this is just very, very, very difficult. Doable, but difficult. And so to me, the dream is that we find a way to create some intermediate definition language that allows you to do that. At least it spans a little bit across.
Jeremy, what's your prediction?
I think it's about the right tool for the right job. To Arun's point, one doesn't alleviate the need for the other and vice versa. Like, we have cheap storage that's relatively slow, and we have fast storage that's really expensive. It's about the right tool for the right job. It's not there's not a right answer in the sense that everything, now that we have great streaming technology, everything should be streaming. It's about, what is the problem I'm trying to solve? All of our technology does not exist for the edification of itself, right? This all exists in furtherance of solving a business need. If we can solve a problem adequately well with batch processing, and that's cheaper for that matter, I would advocate for batch processing. If my use case necessitates streaming, then I'm really glad that we have streaming solutions as well. But I don't think it's we have to choose one versus the other, or one will dominate the other. It is purely going to be based on what is the best tool for the job.
Very well said. The last question to wrap up this session: what is the one overlooked trend of data warehouses, or maybe you can broaden that to data analytics, that will emerge in the next 5 years? It can exist today, just small, but one that might be overlooked or not the mainstream yet.
I'll go out on a limb here because this is a little bit out of my area of expertise. But the way I see this is that a lot of these things are cyclical. And so what I mean by that is I think we'll see new types of data, or new data types rather, into the data warehouse. So I think back 15 years ago, and for those of you who are as old as I am, you'll remember things like Documentum and these other large CMSs that supported, both relational data and blob storage data, but like images and video manipulation. And we moved away from that. And I think for what it's worth, we'll move back to a place where we get to have alternative and more unique data types that can be queried and manipulated within our data warehouses.
Great. Boris and Arjun?
What to think?
The one that I actually think is overlooked is the importance of just data catalog. I think it has existed, but the one that is democratized into anyone access to business users, I think that hasn't really, and DBT actually fulfills a lot of that functionality and give that flexibility to users. But I would see that being more and more mainstream, where people have a common knowledge of where data comes from, what's the definition of it. I think that is a definitely underutilized utility.
Yeah, that's a great one. What I was gonna say is with these concerns of data privacy and data sort of users having their right to delete their data, something that we really have to get very good at, which we don't really have the cleanest story here for, is data deletion, right? So a customer, as we have this explosion of tools, as we have this explosion of copies of data sitting out everywhere, when a customer shows up and says, I want you to delete all of everything you know about me because I'm leaving your service and it needs to be gone in the next 48 hours. That is an immense challenge, right? So you have to propagate that delete everywhere throughout your pipeline. And fairly soon, you're gonna have to propagate that through to some machine learning model that is being trained on their data and having to evict that out of that too. And that's something I think we are overlooking right now. It's not just about where the data lives, it's also about having clear termination points for how long the data lives. And I don't think we're barely scratching the surface in solving that problem.
Totally.
Yeah, I think the data catalog is a good one, Jennifer. I think describing data in a way that is not overwhelming is hard. And we were talking about this earlier. And so this came to me, like we were talking about this in a DBT conversation I had a couple weeks ago with Drew. And it was, this idea that when we talked about latency earlier today, like you can't even mark that. You can't even trivially understand the latency like of a field, right? You can annotate that within another field, but it's not easy to understand. And so data catalogs, I think, might help solve for that to some degree, and kind of spread that knowledge through the system. I think it's an interesting space for sure.
Awesome. With that, it's a wrap. Thanks so much, Arjun, Boris, and Jeremy. I really enjoyed this conversation, and I'll see you guys on Slack.
Thank you so much,
Jennifer.